All right, so today we're going to be doing just a brief introduction to give you enough information to be able to do today's lab. I'm going to encourage you to review the lecture materials that you had on this topic to make sure that you're understanding the kind of theoretical background behind what the experiment will be having you visualize today. So we're going to be dealing with work and energy and the work-energy theorem. And specifically, we're going to be dealing with a type of energy called kinetic energy. And kinetic energy is the energy of motion. And so, in some sense, all we're dealing with is what's called mechanical energy, which is a technical term that just means the energy of objects that are moving around. And so, some definitions. We will have work, and we'll talk more about what work is in just a second, and at least as a physicist use it. And for that, we will use the letter W. We have kinetic energy, which again, as we said, is the energy of motion. And so we will call that KE. And then finally, we will, it's not technically something about either work or energy, but it is something we need to understand, which means change in. Okay? And change in we represent by delta. And anytime we see a delta, anytime we have a change in, the change in is the final value minus whatever the initial value is. And again, you'll see this in just a second in a little bit more detail, and hopefully that'll make a little bit more sense. But these are the kind of the three main things that we need to know, although each of these will have some sub things behind them. So let's start with work. Okay, the work W. Well, work, in the physicist sense of the word, is a force applied on an object that causes it to move through a distance. And so let me imagine that I have, say, a flat table, and we will say it's frictionless. And as we understand work, we'll understand that a little bit more. And I'm going to put a block that's going to have some mass m on it. Well, if I apply a force on that block, so a force, and we generally label forces with the letter F, that if I apply a force that and the object moves in some distance that is either parallel or anti-parallel. So the blue arrow I just drew is parallel. So we're going to move through some distance. In this case, because the two of them are parallel to each other, I'm going to say that the work is equal to the force times the distance. If I have another situation where I have a block and I'm still going to apply that force in the same direction, but even if I'm pushing to the right, if the block is actually moving to the left to some distance, and again we'll see in a minute that this means it will slow down, then I would say in this case that the work is equal to minus the force times the distance, because the work and the force are anti-parallel to each other. And again, if you review the lecture, you'll understand what that physically means. Now for today, we're going to be dealing strictly with the case where the work, the force, and the distance are simply parallel to each other. Okay. So that is work, and it's a key thing to remember. We now have our definition of work that we need to know for this lab as force times distance. And again, it's either plus or minus, but in our case, all of our works and forces and displacements will be parallel. And you'll see that in the experiment. Our next thing is energy. And in this case, we're going to specifically be talking about the mechanical energy or the kinetic energy. Okay. So our kinetic energy, as again you saw in lecture, has a definition of 1/2 times the mass of the object times the speed of the object squared. Now, you will hear the words speed and velocity used And while they are technically different things, for our purposes, we will consider them to be the same thing. If you want to be careful, the speed is the magnitude or the value of the velocity. But for our purposes, we're going to be talking about speed and velocity as if they were the same thing. But they aren't, and I do want to be careful with that. All right? So we now have our work, and we have our kinetic energy. And so what does the work energy theorem tell us? Well, the work energy theorem tells us that when I do work on an object, it will result in a change, that's that change that I talked about, of kinetic energy, which in our case would be the final kinetic energy minus the initial kinetic energy. Now, in today's experiment, we're going to be careful. We're going to say that we're going to start from rest, which means that our initial speed will be equal to 0. That's what being at rest means. And so if I were to write this out, well, we know our definition of kinetic energy is 1/2 m. Now remember, we're talking about the final, which will be the final speed squared. And that will be equal to, minus 1/2 times the mass times the initial speed squared. But remember, we said that we're going to be starting from rest, so our initial is going to be equal to 0. And so our kinetic energy change will simply be equal to our final kinetic energy, or 1/2 mv squared. So the work done on the object is equal to 1/2 mv squared. Okay. So I want to star this because what we will measure is the speed of our object, and we're going to give you the mass. It depends on what car you have. We're going to be measuring the final speed of our object, okay? And by measuring the final speed of our object and knowing the mass, we can calculate the work done on it. We also know that when we take these cars, and there'll be a second video that'll walk you through how the experiment actually runs, that the work will be equal to the force applied on the car times the distance that it travels. And hence, we are going to connect, let's call this equation 1 and equation 2, and we're going to see that the work done, in other words, the force applied to the car times the distance it travels, will be equal to its final kinetic energy, or 1/2 mv squared. So again, this is a very brief summary. I don't expect you to fully absorb the entire lecture in this. If there's any questions, please go back and review your material, and make sure you ask your instructor if you have any questions.